Hello students, good morning. So today I have taken another one example, exercise 8.1, class 9, problem number 6. Here ABCD is a parallelogram where A angle is bisected by the line AC. Okay, we have to prove this C angle is also bisected by the same line and ABCD is a rhombus. So first you prove Roman 1. Roman 1, we have to prove that C angle is also bisected. Okay. Now listen that ABCD is a parallelogram. No, since it is very simple, ABCD is a parallelogram. So the angle, this one parallel this, so this one and this one are same. No, BAC equal to BCA and angle BAC equal to angle BC. So these two angles are, that means alternate interior angles are equal because it is a parallelogram. So AB parallel BC and AC is a transversal. So that's why I can write this one. Now angle, and see that BAC equal to angle BAC. It is given. This one is given. Now this two angle equal. This implies BAC. So that these two are equal. That means BCA equal to BCA. Now, this implies, you see, this implies angle C is bisected by AC. So you see the proof is very simple. Okay, just ABCD is a parallelogram, then we have done. Okay, after this we have to prove that it is a rhombus. Now what is the definition of rhombus? Rhombus is nothing but it is a parallelogram. But in this problem, ABCD is a parallelogram. It is given. So no need to prove again that ABCD is a parallelogram. It is given only. Just you have to prove four sides are equal. No. So four sides are equal. Just you see here. From part 1, one thing you observe here. Can I say all these angles are equal? All these angles are equal. Why? Because you see, this one angle equal to this and this one angle equal to this. I have proved all. Now, just I have done. So, their alternate interior angle is also equal. That means all angles are same. So, from part 2, if you want to prove, right, by part 1 or Roman 1, we can observe that this all angles are equal. That means BAC equal to BCA equal to that BAC equal to BCA. These all angles are equal. Okay. Now you see, any one triangle you take. This triangle. So in triangle ABC, these two angles are equal. BAC equal to BCA. What property we have? In a triangle, if two angles are equal, then their opposite sides are also equal. So I have written this one now. So that means this implies BC equal to AB. Okay. So Reason if you want, here you can write the reason. What will be the reason? In a triangle, if two angles are equal, then their opposite sides are also equal. So easy. Now similarly, these two, similarly that AD equal to BC. Similarly, we can show that from here on. But you see, is BC equal to AB or not? BC equal to AB or not? BC means I am writing it. You say BC means AB, okay, and AB means what? BC, and AB means what? This one I am writing. AB means BC. So from this one, can I say that all these sides are equal? No. Okay. So therefore, ABCD is a rhombus. Okay. So you see the proof. No. Now just you think. Okay. Someone can say, sir, if it is a parallelogram, all sides are equal, then it may be a square. But you see the diagram is given, it looks like a square, no neighbor. Okay. If you want, you can prove in another way by joining B and D. That ABCD is a square, parallelogram, and their diagonal bisect each other at right angle. Then it is also a rhombus. So that way you can. Okay. I think it is very clear. No confusion. Okay. So next, I have to pause the video because we need to draw the diagram. Otherwise, video will be lengthy. So okay, students. Next, I have taken one interesting problem. Problem number 9. If you have the textbook, you can see the question. In the question, it is given that A, B, C, D is a parallelogram. Okay. After this, they have joined this diagonal BD, and on that diagonal, okay, they have taken the 2 points Q and P in such a way that BP equal to B. That means this portion equal to this portion. This information is given from the question. Okay. After this, you see, here 5 sub questions are here. Okay. So first one sub question, what congruency we need to prove. So it is very simple. The triangle is also given. You take the triangle APD. So how to write that? Roman 1 in triangle at APD and triangle what? CQB. CQB. So search this two triangle APD. Which one? APD. That means this triangle and this triangle. Now CQ. Okay. We have to prove this two are congruent. So 3 property should satisfy both the triangle. No? So first, this one equal to this one or not? Because it is a side of the parallelogram, so opposite side must be equal. So AD equal to BC. Okay. Here if you want, sorry, opposite side. Okay. This one, you can write the opposite side. Okay. Opposite side of parallelogram. Opposite side of the parallelogram. Okay. After this, this side and this side are given. So BP equal to BP. What? It is given now. And more one property equal. Just you see, this angle and this angle are equal or not. Just before that problem I have done this line and this line parallel. So this is the transversal alternating line. So you can write angle A DP equal to angle CB. Here if you want, so you can write alternative. Okay. So G we have written. After this, triangle APD congruent triangle CQB. By which property you should mention? You see, this angle is included in between two sides, so side angle side. So one number I have done. Next, AP equal to CQ. That means AP equal to CQ from this number two. So if you want that AP equals to CQ. Okay. Why? As triangle APB congruent triangle CQB. We have already proved, so no need to prove any. After this, you see triangle AQB. So I'm writing this in this side. Okay. So number 3, triangle, which one? That AQB and triangle, which one? That CPD. So again you find out the three conditions. AQB, where is the triangle? Now on that triangle, this is triangle. No. So again that AB equals to CD by the same opposite side of the parallelogram. You can write reasoning, write it down. Okay. So after this, you see this side and this side I have written. No. Moreover, again on that two triangle, this and this are same by the same way, but here you have to write BQ at the first and then BP. This is the given. No, given. Okay, obviously. After this, now these two are equal or not? Because this line are parallel. Okay, so now angle ABQ equal to angle CDP. Here again alternative. Okay, again I have written three properties. So triangle AQB congruent triangle CP by again side angle side property. Okay, and the Roman 4 you see, again AQ equal to, that means this one and this one are same. No, so Roman 4, that AQ equal to CP. So by CP you can write. Okay, by CP or as this two congruent, so by CP. And after this, APCQ is a parallelogram. So 5 number already done. You see, this 5 number. No, here into AP equal to CQ. So this side equal to this side, and this side equal to this side. So 5 number, right? We have that AP equal to CQ and AQ equal to C. So in a quadrilateral, if opposite sides are equal, then it is a parallelogram, and it is 100% sure. Okay, so this too implies that APCE is a parallelogram. Okay, so students, these are the 2 problems I have done. So try to solve more problems, okay, by using some properties and basic concept only. Just you have to use the basic concept. Okay, so thanks for watching.